In part 2 of the series, we take on an understanding of the fundamentals of C# programming and run through some simple exercises to develop an understanding of how C# code can be used with Unity. To create a script in our assets folder, let's start off by just creating a folder, and let's just call this scripts. We can open that folder by double clicking on it, right click, click create, C# script, and we can just call this whatever we want. We can call this test. For this script to actually be executed, it needs to be attached to a game object. So we're going to attach it to our cube. So with our cube selected, we can click on our test script and hold and drag it over here to the inspector, and then let go, and then you can see our test script is there. And we can actually right click on that and click edit to edit our script. This will automatically launch Visual Studio. So whenever you create a new script, it will look something like this, or most likely exactly like this. By default, it provides these two methods, start and update. So anything that you write, any code that you write inside the start function will be executed at the start of the game, and anything that you write in the update function will be updated every frame. So frames are kind of like frames of a movie, right? Most movies are something like 24 frames per second. And what happens is that, say your game is running at 60 frames per second, then all the code inside this update function is going to be executed 60 times every second. Whereas here at the start, it will only be executed for one frame, so only once, before update is called. A great way to understand how the start and update functions work is to use the debug.log method. We can start by within these parentheses here, within the start function, we can actually start typing debug.log like this, with a semicolon on the end. And within here, within quotations, we can write something like start. We can write whatever you like. And then hit Control S to save. Now going back to our editor, if we click on the console tab and hit play, we should see the word start pop up here. It says start, and we can see it happened one time. So I'll just close that. Now we can go into the update, debug.log, and let's just write update with the semicolon on the end. So now this will be called every update or every frame. Now, depending on how fast your computer is, it will write update more or less times per second. So if we hit play, we can see start, and we can see update is here. So 500 times, 600 times, 700 times, 800 times, and that'll just keep going up and up, but we can see start only was called once. Now if we unselect collapse, and then we click on the slider and drag it all the way up to the top, you can see here start was called first, and then update was called, and update was then just called over and over and over again. If we just want to, we can just get rid of this in update now. So another thing about programming is that anything that you write in the script is executed from top to bottom. For example, if I want to debug.log, first, and to do this, I'm actually hitting home to bring it to the start, holding down shift, pressing down to select that whole line, Control C, and you see my cursor has already been brought down automatically below, and just Control V will paste that, and I can press Control V again, and I can double click in here to select second and third. I'm just using the arrow keys. Let's just change this to uppercase, because why not? Cool. So now you will see when we play this, it will debug log first, second, and third in that order, and it will execute in that order every single time you run the application. So if we hit play, here you can see first, second, third. And it did all of this in just one frame. Cool. All right, so now we have an idea of how code is executed. The next thing to look at is variables and manipulating data. It's quite simple. In fact, code, just programming in general, is the fundamental concept of all programming. It's about storing information and then doing stuff to that information using conditions and such. The variables that we have, the main variables that you will work with are bools and ints, floats, and strings. So just to go over these four main variables, a bool is a true or false variable. It can either be true or false. By default, it is false. An integer is how we store a number, a whole number, 1, 2, 3, 4, -5. You can store a fairly large number in an integer, but it can't store numbers like 4.5 or 4.3 or any decimal numbers. That's what a float is for. A float is what lets you store decimal numbers. A string is what lets you store words, text. So if we want to declare a variable, we can say private bool, and we can call these variables whatever we like. I can call this foo, and then we put a semicolon on the end. Now, in our start function, see, Booleans are mainly for logic checking. So if statements, is you know, is it true? Is it false? If it's true, then do this. If it's false, do that, or vice versa. So right now, foo just has a value of false by default. But let's say we want to make foo true. Okay, so we say foo equals true with semicolon. Now foo will equal true. So if we want to see what foo equals, we can actually debug log this. Debug.log foo. And now if we run our application, we see true here. So to use a Boolean in the form of a if statement, we could say something like if, and I'm just hitting tab twice, if foo equals true, we can dot log. We could even just say banana, and then we could say if foo equals false. I'm just gonna, oops, sorry, 2 equals. 1 equals is for assigning a value, 2 equals is to compare the value. I can just copy this. So I'm clicking Shift down to select that line and Control V to pop it in. And we can say apple. So if foo is true, say banana. If foo is false, say apple. And we can get rid of this debug.log foo. So foo is true. It should say banana in the console. So if I go to the console and hit play, it says banana. If we stop that, and let's say foo is going to be false instead, Control S. So now foo is false, it should say apple. And you can see it says apple. So that's how Booleans work. So the next variable, the next variable we can look at is a integer, int. And let's just call this one, I don't know, let's just call it my integer. Or my int. Let's just call it my int. Cool. Integers, they store numbers. By default, an integer will be 0. We'll have a value of 0, but we can set it to whatever we want. We can say my int equals 5, like that. And if we debug.log my int and hit play, then we have 5 here. That spits out. Fairly simple. Now we can actually do math. We can do, we can easily do some simple math just with code. So we could say we could debug my int plus 3, for example, and it will spit out 8 in the console. We could debug, minus 2, it'll come out as 3. We could multiply by 2, give us 10. We can, that's the star for to multiply, and divide by 2, which would give us 2.5. So, or 2.5. So that's how integers work. You can also, we could call this hat. Oh no, hat. Now we could say hat equals 3, and let's create another integer. Let's call this dog, and we can do something like dog equals my int plus hat. Oops. Now if we debug log dog to the console, it'll come out as 8 because we're adding that. So integers kind of work like that, and then floats work in the same way. We can get rid of all that. Private float my float, and we can assign an integer to a float. We can say my float equals 2. That's fine. But let's say we wanted to say my float equals 2.5. We have to put an F at the end and then put a semicolon here to basically say that this is a float. Now, let's say we were trying to assign that float to my integer. It's not going to let us. You can see this red underline means that there is an error, and if you put your cursor over it, it will tell you what the error is. So here, cannot implicitly convert type float to int. Cool. So one of the quirks about working with integers when programming is that when you divide two integers and it comes out to a decimal number, it will actually round that value down. So if you were to say something like 5 divided by 2, so dot debug.log 5 divided by 2, it will actually come out as 2. But if we say 5 divided by 2.0 f, then it will actually debug out as 2.5, because we're actually dividing a integer by a float rather than an integer by an integer. And then the last variable type is the string. Oops, string here. Let's just call this my string. Whoops, my string. And to assign a string, we can say my string equals, with the quotation marks, we can say hello with a semicolon on the end. Debugging it will come out like that. And you can add strings together. You can say, we can call this one another string. We can call another string. We could say that equals world, and we can say debug log, and we can say my string plus, let's make a little space between them, and then another string, and what we'll get is hello world. Yeah. So that's the basics of how to work with various types, variables, and the last property of a variable is the access modifier, which is here, as you can see, private. There are many different access modifiers, but the main ones that you'll be using are private and public. So private means that these variables can only be accessed through mentions within this script, whereas public actually lets you access those variables from other scripts and also from the inspector. So if we change all of these modifiers to public, and there are other ways to make a variable private but also accessible in the inspector through a serializable keyword. But if we now Control S, save, go back to our Unity editor and we select our cube where we attach the script, we can actually see all of these variables in the inspector. This was foo, this was our Boolean. It appears as a checkbox, true or false. Integer can be anything. My float, we could say, 5.6. Here you don't actually have to put the F. That's fine. And string can be hello world or whatever you want it to be. This is great if you have a script where you want to adjust certain properties, on the fly if you're doing testing, or you just want to customize it. Maybe you have the same object, many different cubes, but maybe you want one cube to have a different number to a different cube, or a different value, or a different name. So that's a great way to be able to do that. Whereas if you just had in here start, if we changed my string to maybe it's called my name, and we said, my name equals, Sam or something. Oops, sorry. Then every single cube that has the script on it, their name will always be Sam. Which is actually a good opportunity to give an example of having multiple objects. So let's have a public string my name, and maybe let's say a public int my age. Great. So let's go back into here. Now let's just say let's just say in start we're going to say my name equals, let's just say Sam, and my age equals, I don't know, 100. Let's say my age is 100. So if we go back to our editor, now remember this is in the start function. Even if we set this to Bobby, even if we set these variables here, they're going to be overwritten at the start of the game. We go below here, debug.log, and we say, hello, my name is plus my name. My name is Sam, and I am my age, space, years old. Oh, and the plus here. Cool. So when we play this, it should say, hello, my name is Sam, and I am 100 years old. So this is a good opportunity to show the difference between making the variables accessible through the editor as opposed to hard coding them in the start function. So if I change this to private, here, save, and go back to our editor, you'll see these properties will disappear once it compiles. Now, if I, with my move tool selected, I can actually press Control D. Now you can see we have cube and cube1. This is the duplicated object, and we can drag that over. Now we have two cubes, and they both have the test script attached. Now, if I hit play, they're both going to say, hello, my name is Sam, and I am 100 years old. Both of them have said that. Now, what happens if we have two cubes and we want them to have different names and different ages? Well, because they both have the same script, this script here, they're both going to say the same thing. They're running off the same information. But if we don't assign these variables here, change this to public, like here, and go back to our editor. If we select this cube, and let's make the name Bob, say Bob is 4 years old, and let's say this one is Janet, and Janet is 50 years old. Now, if we hit play, we will get two different console logs. Hello, my name is Janet and I'm 50 years old. Hello, my name is Bob and I'm 4 years old. So you can see how by having public properties, we can have two objects using the same script, but they're able to have different properties.